Hello, my name is Brian Buckley, and I'm the director of the EOHSI Analytical Mass Spectrometry Facility Core. Now, mass spectrometry is the measurement of unknown or known compounds using their mass to charge ratio. And we focus primarily on small molecules, and most of these are environmentally related. So, our investigators at EOHSI may bring me a sample of one type or another. Environmental samples, biological samples. We could be analyzing human hair, we could be analyzing sludge. It doesn't matter. What we're trying to do is figure out how much and what are the environmental contaminants or the things the body turns them into, the metabolites, and we use mass spectrometry to make those measurements. Now, mass spectrometry uses the mass to charge ratio. So it's kind of like differentiating things based on what they weigh. Okay, we're talking about mass instead of weight, but the principle is kind of the same. And what we can do is we can measure all sorts of environmental contaminants and the things the body metabolizes them to be using mass spectrometry. We have two types of mass spectrometry. The first is called gas chromatography mass spectrometry. I'm going to show you what happens is we can separate the compounds with a gas chromatographic column. And then they are separated based on their boiling point. Higher boiling compounds come out later, lower boiling compounds come out earlier. When they come out, they go into a mass spectrometer. And these are ion trap mass spectrometers, which means that we can run multiple mass spectrometric experiments. Or in other words, we can select an ion, we can break it up, we can choose one of the fragments, break that up. We can do that as many times as we want. And the reason we do this is because there are lots of things that may start at the same mass or the same weight. But as we break them up, as we create puzzle pieces out of the big picture, there are only certain compounds that would have a fragment that corresponds to a particular weight. And then as I continue to select smaller and smaller fragments, the process becomes much more selective. So with the selection that we have, we'll start with a sample. The sample may have multiple contaminants in it or multiple things that we just want to analyze. We'll inject the sample, it'll go through the column, and it'll come out, and the mass spectrometer will tell us how much and what the samples are. And we can select a lot of different ways to introduce it to the instrument. We can use a regular needle if the compound is in a solvent. Or we can use something called SPME, solid phase microextraction, which allows us to sample things in the headspace, volatile compounds that when heated are in the vapor phase on their own, or we can put the sample in the water and let the contaminants migrate to the SPME fiber. Once we have the compound in place, we can analyze it and we can determine unknowns by selecting against a library. So the mass spec might create a fingerprint just like you and I have fingerprints, and we use that fingerprint in comparison to a library of compounds to determine what the unknowns are. So for example, you may have a mix of many compounds, but the compounds themselves will have mass spectral libraries that we can search against. We can select and look for what we call hits or identifications in the library. Once we know what the compound is, we can count how much signal is produced to figure out the concentration of the unknown. Determination of unknowns is very important. One of the projects that we used this was to look for lots of unknown contaminants in drinking water. Drinking water is regulated for multiple compounds and metals, but not all. And there are far more compounds that are in our environment that are regulated in drinking water. So at one point in time, the New Jersey Department of Environmental Protection said, tell us what's in our drinking water. So we scanned the drinking water for every compound that we could find. And we found hundreds and hundreds of compounds. Over the course of about 10 to 15 years, we discovered more than 1,000 compounds that are unregulated that are in our drinking water. The good news is the concentrations of all these compounds are very low. But it allows us to look for things that previously haven't been discovered in our drinking water. And And we've also scanned for other things. We've used this instrumentation to measure concentrations of pesticides, biological samples, such as serum and even brain tissue of people who have Alzheimer's. One of the things that we recently found was that the concentration of a pesticide metabolite, DDE, was higher in Alzheimer's patients than control patients.